Now that we have investigated how we can build proteins, their folding, their structure, and their functions, we also eat proteins, and they are also part of our diet. They are not as important of an energy source or the generation of ATP as carbohydrates or lipids are, but they can be used as sources of ATP. However, breaking down and eating the proteins, providing those amino acids for them to then build up our proteins for their enzymes, their functions, is a really important process. We're going to go through and look at how we can take these proteins and digest them all the way through ATP formation. Starting with denaturation. Because proteins are folded and they have those interactions between the R groups and the backbone with the intermolecular forces, hydrogen bonds, ionic forces, all of those attractions. That makes it very difficult for any enzymes to come in to start breaking or hydrolyzing those peptide bonds. Therefore, the first step in the digestion of proteins is we have to denature them. Denature means to remove its nature, to remove its purpose. So we are going to unfold those proteins. When we unfold the proteins, they're losing their biological activity, their purpose, their function, which means they're no longer usable. Doing this by disrupting the secondary, tertiary, and quaternary structures. So we have this normal protein, right? And you can see that it gets denatured. Depending on the process of the denaturation, it can refold and go back to its original form, but we are going to be focusing on keeping it denatured so that we can then start to break those peptide bonds and take the amino acids through the catabolism process. Looking at the methods we can use to denature these proteins. You're probably wondering why there were eggs at the beginning of this video. It's just to make you hungry. Eggs. In the egg whites, that is the highest concentration of protein in the egg. The yolk tends to be the higher of the cholesterol or the lipids. We can use heat, cooking, to increase the kinetic energy of all the molecules in there. But as we know, when we increase kinetic energy, we can disrupt those intermolecular forces, weakening them. And so that disrupts the R group interactions and the hydrogen bondings, causing the proteins to denature. And when it's turning white, it's just kind of creating like this lattice structure, changes the color of the protein, so light can no longer pass through it. So translucent egg white is our folded functional proteins. The white of the egg whites, when it's cooked, they have been unfolded, denatured, and they kind of restructure so light can't pass through. This process is irreversible. You can't uncook an egg yet. UV light, it serves the same purpose because UV light is high energy, so we can use UV light to disable or denature proteins, which is why it can be used to sanitize spaces. It was very common to use UV light during COVID because it can break down the protein envelope that the virus sat in for its protection, because it'll denature the proteins there and then the virus is no longer protected. So whether we're using heat, infrared light, UV light, or any other ionizing radiation, all of that can work on permanently denaturing the proteins. Next is using acids or bases. So if you've ever had ceviche, I have not. Sounds disgusting. But apparently you can take fish and you put it into lemon juice or lime juice. Those are very acidic juices. And so the acids are going to preferentially want to interact with those R group interactions and hydrogen bonds. So it goes in and essentially disrupts those R group and hydrogen bonds, and the ions of the acids and bases will go in and then be attracted. So like our carboxylate ion is like, H plus is like, oh, hello, carboxylate ion. I'm going to hang out with you now. And so even though you're not using heat to cook this fish, the acid is doing the same exact job of denaturing the proteins to cook it. Organic solvents, why we can use ethanol, isopropyl alcohol, hand sanitizer to help sanitize, clean our surfaces, our hands, is because that alcohol they're smaller than our proteins are. So those small alcohols have hydrogen bonding, so they can wiggle their way into that protein, and on those R groups, or in the secondary and tertiary, the secondary alpha helices and beta sheets can go into those hydrogen bonds and be like, oh, I'm smaller. Let me come in and cozy up. And because they can get in there, it's going to start to separate those interactions, causing the separation. Now, typically we want that mechanical energy or mechanical processes as well, because that's what's going to slough it off your hands. So with the organic solvents, sometimes those can reform back. We can have heavy metal ions. So this is where lead poisoning, mercury poisoning, silver poisoning, copper poisoning can come in from. So with our heavy metal ions, you can see that on this protein structure, so here we have lead, and then we kind of have that backbone. So it's going to interact with those R groups, or the oxygens of those R groups, changing the way in which the protein is structured. It'll also, I know copper and sulfur have a very strong attraction to each other as well. But the heavy metal ions are going to go in and they change the formation of the protein. So the proteins coagulate around these metal ions and they lose their function. So with the Mad Hatter disease, we used mercury to keep the form of the top hats, and it would sit on the hat maker's head as they were trying to get that form right. So mercury was seeping in through the skin, and then it can interact with the proteins in the skin, but also in the brain, permanently disabling the proteins within the brain, and that's why you started seeing those symptoms of the Mad Hatter disease as well. Lastly, agitation. So this is the mechanical process. If you've ever made whipped cream, you are mechanically breaking, disrupting those forces. But this is reversible, because if you let whipped cream sit long enough, it's going to separate into the fats and the water and the proteins, and you have to re-whip it. So that's just a temporary process of separating out the proteins, but they can go back because there's nothing in there to permanently separate and disrupt those intermolecular forces. So these are just different ways in which we can start the process of denaturing so that we can then eat these proteins.